Like we just say like,
I reckon it.
welcome to this new class.
I reckon
And
it.
what's your
Okay, so today we're looking into the differentiation of the functions with the parameters. First of all, what is parameter? Let's say if we have function y equal x squared plus c.
This was on the economics.
Function is x squared. What does parameter c changes?
The y-intercept.
It's moving its up or down.
Yeah.
Yeah.
So all those functions,
So much of a circle.
they will have a y-intercept at different points. So we will have this, will describe the family of the quadratic functions. Changing parameter, we're moving it up or down, but the function itself remains the same. So let's consider, because usually the function with the parameters is the question the student struggles the most on the exams. So let's consider some examples. The functions with the parameters. So let's consider the next question. We have function f of x equal x squared minus ax plus 9. And we know that it has stationary point at x equals 3. Question is, what is a? How we will do that?
Sub it. Sub in x.
And how it will help us to find a?
Because you can make a the subject.
Because we know that this is x coordinate of stationary point. To stationary point. What we're doing to find stationary point?
Oh, gradient equals 0.
First we find the derivative. So what is f dash of x?
2x
equals?
2x minus x. 2x.
2x
Oh,
minus a. 2x equals minus a.
Maybe
And stationary point, what derivative equal at stationary point? 0. So we have 2x minus a equal 0. And it happens when x equals 3. Now here we can substitute x equals 3. So you get 2 times 3 minus a equals 0. A equals 6. Make sense?
Yeah.
Thanks for watching YouTube.
Next example. We have
Make sure to like and subscribe.
we have now cubic function. I will suggest that taking notes will be helpful.
I didn't have that book.
Let's consider now cubic function. X cubed plus bx squared plus cx plus d. And we know about this cubic function that it passes through the point 0, 3, and it has stationary point at 1, 3. And based on this information, we need to find b, c, and d. First, let's substitute the point through which it's going. We're substituting 3 instead of f of x instead of 0. Instead of x, we substitute 0, and we get value of d straight away. D equals 3. Substituting this point into the formula for the cubic, we get d equals 3 because x equals 0, 0, 0. Make sense?
Mm-hmm.
Now, to use stationary point, we need to do what?
Y equals 0.
Differentiate it. Stationary point is when derivative equals 0. So we need to differentiate. Derivative will be equal f dash of x equals
3x squared
3x squared, yes,
2bx
plus 2bx
yes,
plus c.
plus c.
plus c. Now, as this is a stationary point, what this expression will be equal?
0.
0. So we have 3, and x equals what at stationary point?
1.
1. So we substitute this point, 1, 3, into the expression for derivative. We have 3, derivative equals 0. We substitute only x value. So derivative equals 0 equal 3 times 1 plus 2b plus c. So we get our first equation, 2b plus c plus 3 equals 0. But we have 2 unknown and 1 equation. Not enough to find them. What we need, how we will get the second equation?
Simultaneous equation.
How we'll get second equation?
Oh.
Natural derivative.
Hmm?
You sub in 1 and 3 into the other, like 0 and 3, oh no, right.
We
1 and 3,
substitute
yeah.
1 and 3 into
Yeah.
the original
That's fine.
function. So we will get 3 equal 1 cube plus b times 1 plus b plus c, and d we already know, plus 3. So we get second equation, b plus c plus 4 equals 3, or b plus c equals
What?
Negative 1.
negative 1.
Oh.
Okay, so now we have two simultaneous equations. What is the easiest way? And I move 3 to other side as well here. So 2b plus c equals negative
Minus
3.
3.
Yes,
So we have
if you
B.
minus equation 2
b
from equation,
equals negative. No, equals negative 2.
B equals negative 2 and C equals 1.
b equals negative 2. So c equals 1. Make sense?
Yeah.
Okay, that's the idea how you approach the questions with the parameters and differentiation.
That was beautiful.
Ah, so that's back. Nothing
Bye.
new.